Good morning, everyone. So, today we are going to discuss about piston ring, and crankshaft. Piston. The engine piston serves several purposes uh, that are transmission of explosion force to the crankshaft through the connecting rod, act as a guide for the piston ring to seal the piston in the cylinder, act as a guide for the upper end of the connecting rod. Piston has to work under the most severe mechanical and thermal condition. Therefore, it must satisfy the following requirement: maximum load carrying capacity with minimum weight, maximum heat standing quality with minimum expansion, maximum hardness with easy machinability, maximum hardness with maximum flexibility, quick dissipation of heat, resistance to corrosion and wear, minimum permanent deformation, high durability, low cost. Materials for piston. Materials used for the manufacture of the piston are cast iron or semi steel and aluminium. Their respective merit are given below. Cast iron or semi steel. This is preferred because it is strong enough to the stresses imposed. It has a melting point above the cylinder operating temperature and expand at the same rate as the cylinder and does not generate excessive friction when properly lubricated. Aluminium alloy. It is lighter than cast iron, can be readily cast and machined, and does not generate excessive friction. Due to less weight, the inertia of the moving part reduces, which ultimately adds to the higher speed of the engine. As aluminum alloy piston are subjected to more heat conductivity, the piston heat runs at a cooler temperature. Piston construction. The main part of the piston or the piston head, skirt, ring, groove and lance. The head of the piston is the top surface where the combustible gases exert pressure. The piston head may be flat, concave or irregular. The different shape of the piston head allow for more or less compression and spooling as need for the different engines and fuels. Diesel engine piston may also have a combustion chamber recessed in the head. Rib inside the piston head reinforce it and enable it to carry away the heat from the head to the ring. The skirt of the piston is the outside part below the ring groove. It keeps the piston in alignment. The skirt forms a bearing area in contact with the cylinder wall, which take the thrust caused by the crankshaft. There is more thrust on both sides of the piston. The major thrust, however, is on the side opposite the crank through as the piston goes down on the power stroke. In some cases, the piston skirt is exerted downward on the thrust side to increase the contact area on the thrust side. The piston pin may be offset to one side of the piston center line as shown as G. It may or may not have an relief area as shown as K. The bottom of the skirt may be square or may be of slipper type as shown as H. Some pistons are either fully or partially cut away around the piston pinhole. This is known as known as relief and is intended to provide additional clearance to avoid seizing in case the piston become overheated and expands excessively. Ring grooves, circular groove around the piston which carries the piston ring are called as ring grooves. They are shaped to the proper design to match ring for good condition of oil and blow by. The lower groove has opening for oil collected by the oil control ring to flow back into the crankcase. Piston lands. These are the area between the piston groove which holds and support the piston ring in their grooves. Combustion chamber is a space where the combustion of the fuel takes place. The design of the combustion chamber depends on a number of factors to avoid adequate mixing of the air and automate the fuel, which requires imparting a vigorous movement to the air. Among high-speed diesel engine, a variety of combustion chamber is available. In general, they can be classified as open chamber or direct injection type and separate chamber type. Direct injection chamber, the clearance space that accommodate the compressed air charge, is relatively simple in shape and often almost entirely due to a recess in the piston crown, the cylinder head being flat. The fuel is sprayed through 2 or 3 fine holes at a high velocity requiring an injection pressure of 2800 kg per centimeter square or more. The resulting hot jet enables the fuel to penetrate the dense air and find the necessary oxygen for combustion, aided in most cases by some residual swirl or turbulence set up during the suction stroke by the masking of the inlet valve. This type of combustion chamber is available on engine with a compression ratio of 13:1 to 14:1 and require no auxiliary starting devices. Separate compression chamber. In this design, a separate cell is available in which a part or whole of the air during compression is forced a restricted passage. Communication between the separate chamber and main cylinder is restricted in order to promote efficient combustion through the generation of powerful air and gas movement. The different types available under this category are known as pre-combustion chamber, air cell chamber and air spill chamber. In a pre-compressed chamber, the chamber is initiated in a separate cell. Combustion is initiated in a separate cell in the cylinder head. The resulting increase in pressure causes a mixture of partially blend fluid and air to issue through one or more passages communicating with main cylinder, where there is an excess of air which completes the combustion. In an air cell chamber, the air is again forced during the compression stroke into a separate cell, normally in the cylinder head. Fuel is sprayed usually from a single hole nozzle in the direction of the mouth of the cell and across the main combustion chamber. As the piston begins to descend, the air from the cell rushes back into the main combustion chamber. This produces an through mixing of air and fuel, the principle being somewhat similar to that of blow lamp. A air spill chamber differ from those described above. in that the air is forced into a separate chamber where it gets a definite rotational motion. Fuel is injected directly into the chamber and mixed well with the swirling mass of air. Next, we will see about the connecting rod. The connecting rod is attached at one end to the crank to a crank pin on the crankshaft and at the other end to a piston through a piston pin. The lower part of the connecting rod is split to permit its being clamped around the crankshaft. The split head, known as big end, usually incorporates a babbitt bearing, a bearing lining of either steel backed copper lead or steel backed cadmium silver is also used. The connecting rod must combine great strength with lightweight. It must be strong enough to maintain rigidity in carrying the thrust of the piston during the power stroke. At the same time, it must be as light as possible so that the centrifugal and inertial loads on the bearing will be no greater than necessary. Usually, it is forged from alloy steel and it is made with I-beam cross section. To provide lubrication of a piston pin, an oil passage hole is often drilled along the entire length of the connecting rod from crank pin journal bearing to the piston pin bearing. A hole in the big end upper half feeds the oil to the connecting rod. Oil passage from the oil line drill in the crankshaft. The oil circulates through the connecting rod. Oil passage to the piston pin bearing. Type of connecting rod: split at an angle. Some engines like Escort 335 have the connecting rod split at an angle to make assembly and disassembly easier and to permit the passage of the rod end through the cylinder bore. Offset from shank. On some engine, the big end of the connecting rod end bearing is offset to one side of the rod shank. Offset connecting rods are employed on engine where, due to the design of the engine, the cylinders are not exactly centered on the crank pin of the crankshaft. Inspection and repair procedure. When the connecting rod is removed from the engine, it should be tested for alignment. This is done in a piece of equipment called connecting rod aligner. Bent or twisted rods may be straightened in the aligner with a bent piece of iron. Bent or twisted rods cause rapid wearing of cylinder, ring, piston, and pin wear. This is a result of their tendency to oppose the vertical travel of the piston in the cylinder. Inspecting bearing clearance. Connecting rod bearings that are worn, pitted, scored, corroded, or shown sign for fatigue should be replaced. Bearing failure due to fatigue result from the breakdown of the bearing metal after long application of intermittent and heavy loads at fairly high temperature. The bearing surface is usually covered with fine cracks that extend through to the backing. If portions of the bearing show such sign of fatigue, all the engine bearing should be replaced. Side clearance. The connecting rod end bearing must have a side clearance to ensure that the sides of the connecting rod bearing does not bind on the fillet at the end of the crank pin. The side clearance is measured with an feeler gauge On an inline engine, the side clearance should be from 0.1 to 0.25 mm. The connecting rod should be replaced if the side clearance exceeds 0.25 mm. On a V-type engine with side-by-side connecting rod, the side clearance is from 0.2 to 0.3 mm. Next is crankshaft. The crankshaft is a one-piece casting or forging of heat-treated alloy steel that is of considerable mechanical strength. The crankshaft takes the downward thrust of the piston during the power stroke. The power exerted by the piston through the connecting rod against the crank pin on the crankshaft causes the shaft to rotate. The crankshaft generally has drilled oil passage through which oil can flow from the main to the connecting rod bearing. In the assembly engine, the front end of the crankshaft carries a gear or sprocket that drive the camshaft. Some automobile engines have the crankshaft fitted with the device known as torsion vibration damper, which combats torsional vibration in the crankshaft. As part of vibration damper, there is a pulley with one or more grooves. A V-belt fits these grooves and drive the engine fan and water pump. The rear end of the crankshaft carries the flywheel. Its purpose is to smoothen power impulses so that the engine moves smoothly. Parts of crankshaft. The main part of crankshaft are main bearing journals, that is bearing surface for support on main bearings. Next is crank pin, bearing surface connected to big end of connecting rod. Crank arm or crank arm on throw, opposite which helps provide leverage to rotate the crankshaft. Counterweight, balancing weight opposite the rod channels. Arrangements of crankshaft throws. There are number of factors which affects the design of crankshaft. The arrangement of crank arm is one of them. The firing order of the engine depends upon the arrangement of the arm. The arrangement of the crankshaft throws affect the balance of the engine, the vibration from turning of the shaft, loads on the main bearing, and firing order of the engine. Next is balance of crankshaft. Due to the factor acting on the flywheel and crankshaft and the speed at which they revolve, it is necessary to balance them with great care. They are first balanced statistically and then dynamically. To obtain static balance, the weight must be equal in all directions from the center when the crankshaft is at rest. Dynamic balance means balance while the crankshaft is rotating. Dynamic balance is attained when the centrifugal force of rotation are equal in all directions at any point. The balancing operation requires a special machine and involves the removal of metal from heavy points. In order to obtain rotating balance, the crankshaft is equipped with counterweight, which are usually forged in integrally with it, but in some cases the counterweight are rigidly bolted to the crankshaft. This counterweight are located on the opposite side of crankshaft from the connecting rod so as to balance the weight of the rod. To balance the crankshaft properly, the entire rotating assembly is balanced dynamically. This includes the fan pulley, vibration damper, timing gear, and crankshaft. Flywheel and clutch are corrector part attached to it. Moreover, the connecting rod and piston are all very carefully balanced one with the other so that the rotating mass has as little vibration as possible. So in this video we have seen about the piston, connecting rod and camshaft. So that's the end of our video. Thank you.